Hi, my name is Roger Moss, and I'd like to show you a film that I took of some machines that Moss Machine Tools had made in the late 80s. The family business had a great team and made great machines, but we all enjoyed it thoroughly. Combination of recession, falling demand and some default on payment by overseas visitors saw the end to the company in the early 90s. A great tragedy, but it was part of history. There are no other major players left in that field in the UK. Okay, so the film that we're going to show you, the first one is a big transfer machine which is for making, actually that huge machine is just for putting 6 holes in what we call a planetary carrier. It's part from an automatic gearbox. And what I'd like to say, draw your attention to, is that a carrier such as this in a gearbox generally has 3 gears and 3 pins, and it is a direct analogy to a 3-pin stool. You have a 3-leg stool, it all sits squarely on the floor. You have one with 6 legs, and how many legs are going to be actually sitting on the floor? Well, unless you're very lucky, 3. They needed 6 to try and get greater horsepower through it because it was failing, because it had been designed to go behind a smaller engine, and they got a big problem. If they could get this so that it would drive through at least most of the 6 pins, they might get away with it. We came up with a very unusual method to do this job, and the machine, you will see, uses this method. And what it does, it takes these pieces, different types, there are 2, they're formed of 2 different materials. The first is a steel, which is selected so that the pieces are stamped out like a starfish, and then the fingers bent over like that. They have to be of a material that's very ductile so it doesn't crack on the corners when it's bent. The back piece is made from metal powder sintered together, heated and pressed, rather like the old Bakelite. It has a tooth form in it for driving, which we call a spline, and the 2 are fastened together by electron beam welding. Very interesting, really. The point that had not been really appreciated was not only the fact that you cannot put a tool through there, go through space into another side and know that it was going to be exactly in the same position, but more pertinently the fact that the 2 metals had cut with different characteristics, and if you put the same tool through, then the sintered metal cut like cheese, it made an exact size, whereas the material that was ductile had a memory, and when you cut through it and you took the tool out again, it shrunk back again. So the same tool produced 2 different sizes, so we had to come up with a tooling situation to get around this problem, which indeed we did. The machine also was asked that it could have no men. So these components had to be fed. You'll see them being fed. You'll see them being turned, because they have to be put in the right position, because otherwise the machine could start to put holes in the wrong place. It needed to be exactly in the right place. It goes round. It puts them in position. It puts them in position and then moves along on vertical, we call them pallets. These are little carriages, and they have to stop very accurately. They were stopping within 3 microns. Because you could not, with the equipment we've got, put all 6 holes in together. You had to do 3 and then move it to the next position, and that put the 3 intermediates in. And every operation had to be done like that. So to get the whole lot within 12 microns, every hole, and within size tolerance, was quite a demanding feat. We managed it, we enjoyed it, it was a great achievement, and we hope you'll share our pleasure at revisiting this again. You'll see it all working. There's also machines that you will see on this small 12-minute film that have full walking CNC. There's a machine. We couldn't sell those in the UK. People, although we were being beaten hands down by Japanese companies using computer operating machines, British management wouldn't buy them. The only machine we made, which was quite an advanced one of this type, because you can make anything, it's what people will buy that matters, was sold to Russia. Strange irony. So the only other area where people were willing to consider advanced methods really was the aerospace, and because they were going forward, they had the culture. So the very last machine you will see with a laser cutter, which will cut holes, cooling holes at an angle in jet blades. That's where you could also show your inventiveness. So basically the idea of this film was to say to you, look, here we are, by some quirk of fate, very interesting quirk of fate, when industry is going down, we changed our work to do our hobby of motorcycle engines for Scots, including building new ones and transmissions. Don't think it's all we can do. I've spent my life solving problems, making prototype machines, of which these are just samples, everyone different, everyone had to work first time, no making umpteen prototypes and testing them. It had to work first time, otherwise you didn't get paid. So it was interesting, it was stimulating, and if you need to feel confidence as to whether we can cope with a problem where there's no specialists, then just look at this and think. Thank you. Thank you.